Hello dear students, today we are starting a new chapter, laws of motion. Okay, here we will learn about the force, then we will learn about the Newton's first law, second law, third law of motion. Students, last chapter you understand about motion in a straight line. Okay, means a object that is belongs to the kinematics. Kinematics means that a object moves in a straight line. So what the effects that we learn, okay, means whether a body in motion, how its velocity, its direction, everything that change, that we have learned in the previous chapter, second chapter. Here we will learn about the cause means why that, how, what will be the nature of that force, okay, why the motion takes place, okay, that cause, okay, motion of the body in straight line, so we have learned, but why that motion come into effect, that we will learn here by the three laws of motion, first law, second law and third law, very important. And that's why student, attentively you will watch my lecture, okay, and listen it very carefully. Now students, here the first thing you will learn that what is a force, what is the definition of force. Students, you know that any external effort, okay, I am showing you the page, see the force, that is my hand note, so you can prepare notes in your copy also like this way, that a force is a force, a force, any external effect, okay, in the form of push and pull, you have learned it, okay, in the form of push and pull, and that change the trends to change the size, shape of the body, or students you can say, I'm showing you through this way, okay, here, or you can say that a body is in motion, that force can stop it. Suppose a body is in stop, it can come into motion, so force can stop a body, bring it into motion, or it can change the size or shape of a body, so that is force, okay, that I have explained over here, that suppose that is a mass a, is the force is applying, okay, so force is a vector quantity and the unit is kg meter per second square or Newton SI unit, and CGS unit is dyne. Now students, force is two type, contact force and non-contact force. Here you can see, so contact force, that they are also subcategorized as frictional force, normal reaction force, force by string, force by a spring, or force by collision of two bodies. What is present in your body, that I am explaining. These are contact force. Students, by the name you can understand, contact force means there should be a contact, okay, and another is not non-contact force, means force from a distance, that is gravitational force, electrostatic force, magnetic force. You know, two magnet, if I keep in a distance, then also a force is acting between them, but contact force is not like that. Contact force, always in contact it will happen, there should be a contact, but non-contact gravitational force, you know, suppose you are falling from a 5-story building, somebody is jump and falling, that means gravitational force acting on it, there is no contact between earth and that person, but a force is pulling him, that is gravitational force and non-contact force. So students, one by one we will understand. First you understand that what is present in your book, that is frictional force. I know already, you know that frictional force means contact force, that force which are applied on bodies by making a physical contact with them, okay. So frictional force, when a body slide over a rough surface, students make notes in your copy, that short point, what is frictional force. So when a body slides over a rough surface, a force starts acting on the body in the direction opposite to that, to the motion, okay, you can see that is force of friction, push that side, and it is important, this force act on the opposite direction, where the force is applying, this force is applying on the opposite direction. Main force push, we are pushing the book on that way, but the force of friction acting in the opposite direction. It is very important, students. Sometimes the question used to come where the reverse opposite force is acting when we are giving the force, that is the frictional force. Students, example and definition is important. Only you read the example and definition. Now students, come to the normal reaction. Normal reaction force, you can see here, when perpendicularly force is acting, that is called normal. Just remember this thing, perpendicularly. When a force is giving, force acting downwards, here you can see that perpendicular. Suppose your palm, you are taking a block in your palm, then what happened, that block is giving its force downwards, okay. And similarly, your hand holding it, that means hand is also applying, maintaining its weight, that's why too it is in on your hand, otherwise so it can fall down. So palm is balancing that for weight, that means a reaction force is upward happens, okay. So force, that is the force due to gravity. Force due to weight means force due to gravity, you can say. W is equal to mg, that is the mg acting downwards. So the force what we are giving to holding that block, that force is called normal reaction force, okay. That force, okay. Here it has written that when a body is in place, surface of the body, exact force, okay, downwards equal to the weight on the surface, but the body do not fall because surface exert equal opposite force, that is called normal reaction force. Students, I have prepared notes, I am showing you that page. Here you can see normal reaction force very properly, okay. Should be perpendicular, it should be perpendicular, and perpendicular to the surface and perpendicular to the point of contact. Suppose that is the point of contact, then W is equal to mg, that is the m normal acting perpendicularly, and that mass n is acting, that is the normal reaction, okay. Force always exists in pair. If this place act a force on mass, okay, just zoom it, force on mass called normal reaction, okay. That mass also exert some force on the plane because force exists in pair, okay. Always remember this thing, force exists in pair. And also definition, here also you can see that normal reaction is acting. Suppose a mass on the earth, n is acting downwards. Similarly, normal reaction force is same amount of force is, means mass is applying this force and earth is applying, okay. Here is also a downward force and similar type of upward force is acting, that is called perpendicular force, that is called normal reaction. Now students, coming to the tension force, okay. Tension, you can say a rod or a string or a chain. Suppose you are binding something, here it is properly given, okay. Just 1 minute, 1 minute, sorry. Here you can see tension force as applied through string, okay. When a string, you can see that a body is bind, see here this portion, weight is acting downward, but a tension force is a rigid support, a string is there which hold this body, that means that string is pulling it, otherwise when that body's mass is greater than that string, it will turn down, it will fall down, but somehow it has balanced, that means the tension is equal to W means weight, okay. Here it has written that T is equal to weight of the body, otherwise if W is greater, W greater, then so that will break, and it will turn down, fall down, okay. But somewhere it need to balance, that's why it has in this way. So this force is called tension force, okay. And tension, you just remember it on that way, tension always act away from the point, okay, away, because suppose this is the object you bind here, that means this direction, not this direction, below direction. Below direction means this is the point, so away from the point, arrow should be opposite direction, and that below direction it will be the mass, W. W means weight of the object. Force due to gravity is acting. Okay, so this is the tension force. I think you understand. A force is developed in the string. This is the tension force. Now moving to the next portion. Now students, force exerted by a spring, you can see that there is a spring. Okay, so fixed means there is the force is acting on is, that is called restoring force. Means suppose you are pulling it, when if you release, then stretch, it will come back. So that force, when you are pulling and when it is compressing, a force is acting on it, that is called elongation, that is its elongation. When it is longing, that is elongation, and coming, that is compression. That force is called restoring force. So if you read, you can understand. It's not so much also important, but if you just keep the concept, consider a spring which is one kept fixed. Okay, so it's another in either stretch or compressed. So then that time it is experiencing some force, means it exerts some force, and that is called means opposite. The spring exert force opposite to the direction of the displacement. Okay, when you are pulling it that direction, but force is taking it back. Understand? See, pull this direction, so always check this arrow, which side arrow is there. Tension arrow is always opposite direction, tension force. That's why I told that for the tension, away from the point means the arrow should be opposite direction, where the object is bind. Okay, that is the direction of tension. Similarly here also students, you always remember, okay, direction should be there. All are the vector quantity, force is a vector quantity, so direction should be mentioned over there. Okay, magnitude is there as well as direction, which direction the force is acting. So here magnitude of force directly proportional to the magnitude of the displacement. Okay, so more displacement this side is equal to more force will be, more elongation force will be there. Okay, so similarly you can see normal form of spring when it exerts no force. Okay, both side. Then if you compress means opposite direction restoring force. Similarly you just pulling it means same direction, here the restoring force happens. Okay, so this is the thing. Now force exerted due to the collision, here some term is very important. Suppose that is a body, that is a body, motion a and b come together and collision happens, then the term here right, you students check it. If ab, students, a means on, always remember first one means on a by b. Okay, this is on b by a, that designation is very important here. So you can write that force on a by b and force on b by a is equal to, that is the force, exerted force. So you know when collision takes place, that b exerts some force on a and a exerts some force on b, maybe that is greater and lesser, but these things happens. So that term you can write like this: F on a by b. Okay, and if ba means on b by a, and you can see by the figure that that will be greater on b by a because a size is bigger. Okay, so that's I am saying, after the collision, that collision force exchange takes place, then that will move further away. Okay, after the collision they will just move back. Okay, so that is the thing students, bouncing back, moving away after collision. This is the as a result equal opposite force act on each body. Okay, when two body collide, equal opposite force will happens. Okay, that time they will just move to the apart of the same distance. That force is called force during that is also a contact force. Contact takes place. Now students, come to the non-contact force. You know gravitational force, electrostatic, magnetic. Electrostatic force so you already know. Now just come to the gravitational force. Then very easy, gravitational force, that is the definition is there: force of attraction any mass, that is called gravity. Here it is written: in universe each particle attracts the other particle due to its mass. the force attraction between them is called gravitational force. Remember the definition. And here also the earth also, because of its mass, attract the other body around it. This force is called gravity. Force due to gravity, which we generally consider as weight of the body. Okay, so force due to gravity is also known as the weight. W is equal to mass g, m into g. So g is the acceleration due to gravity, and the mass of our body is equal to weight. Okay, and that is the force what earth is pulling us, is equal to our weight. Now students, I hope you can understand. Now coming to the electrostatic force. Okay, two charged particle repel and unlike charge attract. Okay, this is called that force is called electrostatic force. The force between the charges is called electrostatic force. The force act as between the charged object even when they are separated. Okay, when they are separated, like comb, a comb is wrapped on die here, get charged, and when bring to a small bit of paper, opposite charge get induced. That paper is also have electron, proton, neutron, but all are neutral phase. But when you are bringing a charged particle inside it, beside it, you learn the induced takes place, induced charged takes place. Last year you learn about the electrostatic force, the same thing over here. Okay, so that causes the force on the that causes the attraction. Now magnetic students, so you know when to opposite magnet. So up to this portion today I give the work, you read it. Here is some exercise, you practice the answers. It is very important. Thank you.